Okay, here's this red circle representing the Ferris wheel. And the low point of that Ferris wheel is 1 foot above the ground. This is the line y equals 1. As the Ferris wheel starts rotating, the height of that car keeps increasing. And we want a formula that'll give us the height of the Ferris wheel at any time t. And it takes 12 minutes to complete one revolution. That's like the period, 12 minutes, and then it starts all over again. So this is like a periodic function. It'll take 6 seconds to get to the high point. And since the diameter of the Ferris wheel is 21, 1 plus 21 tells us that the high point is at 22. And the midline is the average of the low and the high point. So this is the line y equals 23 halves, or 11.5. And the amplitude is this distance right here, which is half the distance from the low point to the high point. It's another way to think of it. So the amplitude is 21 halves, or 10.5. To write the equation of a periodic function that meets these qualifications, we need to find out the value for b, and you'll see what I mean by b in a second. The period of sine and cosine is 2 pi over b, so if we solve for b, we get pi over 6. So it looks like maybe y equals 21 halves, cosine of b is pi over 6x, plus there's the midline. Okay, slight problem still. The cosine function starts at the high point, and we want this one to start at the low point. So we can achieve that by putting a minus sign there. Okay, so there's one way to write this equation in terms of cosine. Here's what the graph looks like. I said x instead of t. So as t increases, this box, or this Ferris wheel car, rises. I'll share my screen and show you this happening. Entire screen. Here's the Ferris wheel. Here it is over here. Let's get it back to the start. So every 3 seconds, after 3 seconds, it hits the midline. Another 3 seconds, it hits the high point. Another 3 seconds back to the midline. Another 3 seconds, which brings us to 12. It's back to where we started, and we start all over. Okay, and by the time we hit 33 seconds, the car is back to the midline. So it's 11.5 feet above. Okay, now you could write this, I'll stop sharing, in terms of, oh, well, there's the same picture. Okay, these are the midline point, the high point, and the low point at given points in time. You could write this in terms of sine if you wanted to, by saying 21 sine of pi over 6, that's the b. We have to figure out what the phase shift is to get the sine function to match the cosine. So if I put 6 here and say I got to solve for phase shift, I know after 6 seconds the height is supposed to be 22. So if I solve this equation for k, I'll have the phase shift. And if I subtract 23 halves, multiply by 2 21st, I get a 1 over here. So the sine of this is equal to 1. So this is equal to the inverse sine of 1, which is pi over 2. Multiply both sides by 6 over pi. Solve for k. K equals 3. So there's the phase shift. That will shift the sine graph 3 to the right and make it equivalent. Okay, there you go. Hope that gave you some help. If you have any questions, post a comment.